أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله. I welcome you all to the channel again. Today we are going to solve a problem on work done by a centripetal force. We know that a centripetal force is the force responsible for holding an object moving along a circular path. It is responsible for that. Okay. Sometimes we may be asked to find the work done by a centripetal force. Is this work done zero or non-zero? If it is zero, how can we prove that it is zero? If it is not zero, what will be the expression for calculating this work done? The purpose of this class is to answer those questions in addition to finding the change in momentum of the body as it moves along the circular path. We are going to learn a lot. I am sure you will enjoy this class. Okay, let's begin. The problem says a body of mass m. M is the mass of the body in kilogram, and the body moves in a horizontal circle of radius r at constant speed v. What is the work done by the centripetal force? Look at the diagram here. You have a body here. It is here. It has a mass m. It moves in this direction with constant velocity v. You see that? And this is the center of the circular path. And then the distance from this center, let me call the center O here. From O to P is R. And of course, from O to Q is also R. Okay, so here is the question. What is the work done by the centripetal force? Okay, we know that as it is moving, at any point it is, at this point, it has a force directed towards the center, and we call that force centripetal force. When it is at P, it has that force, centripetal force. When it is at Q, there is a force directed towards the center of the circle. At any point the object is, at any point, if it is here, there is a force directed towards the center of the circle, centripetal force. Okay, the question is, what is the work done by this centripetal force on the object? Okay, to answer that question, remember the formula for calculating work. Okay, work, this is A, our solution for A. We know that work is force times displacement. Please don't say distance, displacement. Okay, we know that the force is a centripetal force, and centripetal force is mv square over r. Okay, multiplied by what is the displacement. Okay, here is the thing. If the object moves, suppose it moves from here and then all the way back to here, the displacement is zero. There is no displacement because its position has not changed. For displacement, there must be change in position. If there is no change in position, let's say I have an object here, I displace it to a new position here, and then I take it back to its initial position here, my displacement is zero. So what is happening along the circular path is that the object is not displaced eventually, because when it started at here, it will always come back to here. So when it comes back to here, no displacement. If the journey started here and it moves all the way back to here, no displacement. When it started here and it moves all the way back to here, no displacement. As such, the displacement is zero, and because the displacement is zero, the centripetal force multiplied by 0 is 0. So it means that the centripetal force has not done any work on the object. So the work done by the centripetal force is 0. Okay, B says that we should get the change in linear momentum of the body when it moves from P to Q, where PQ is the diameter of the circle. Okay, look at the diagram here. Here is the P, here is the P, and here is the Q. P and Q. Okay, when it started from P, when it is at P, since the motion is in this direction like this, at P here, its velocity is in this direction, downward. You see that? And then at Q here, it moves all the way to Q here, so the velocity is in this direction here. Okay, is in this direction here. So when we have vectors that are oppositely directed, do not forget one of them should be positive and the other should be negative. So if I take this one that is downward, if I take it as negative, then the other one I must take it as positive. So this is negative, this is positive. But in any case, the magnitude of this velocity is uniform. It is minus v here, and it is plus v here. This is positive. It is plus v here. Okay. The momentum, it means that the momentum here will be mass times the velocity, and this is minus v. So the momentum at P is minus mv, and this is our initial momentum. This is our initial momentum, P initial. Okay. Then at P, because at Q the velocity is plus v, so its momentum is mv, and this is our P final. Okay, to get the change in momentum, we say change in momentum is equal to P final minus P initial, and this is equal to our P final. You see, P final is mv, so this is mv minus P initial, and our P initial is negative mv. So we open bracket because we already have the, so we put the negative negative mv close bracket, and this is equal to negative. Negative will yield positive, so mv plus mv. We have two identical terms, so we take just one and multiply it by 2 mv. So it means that the change in momentum of the body as it moves from P to Q is 2 mv. This is the change in momentum of the body. I hope this is clear to all of you. Thank you for watching. Assalamu alaikum wa rahmatullah.